Hello everyone, December 13th. Alright, we a little bit struggling yesterday on this one, so I thought about it afterwards. I think we can do this using monotonic stack. That's what I think, okay? That's what I think, so we're gonna try. But before that, let's get today's done first. So it's the first medium problem in a very long time. Difference between ones and zeros in row and column. You are given a zero-indexed binary matrix grid, zero-indexed difference matrix diff is created with the following procedure. Let the number of ones, bless you, and the ith row to be ones row I. Let the number of ones in the jth column be ones column j. Let the number of zeros in the ith row, and okay, so we have all that. Then diff ij is number of ones in row I, number of ones in column j minus number of ones in row I again. So that's the diff, right? The diff between ones and zero for row I, and the diff between ones and zero in column j. Okay, return the difference matrix. Like what? You just compute, right? You just compute. So nothing too special. All right, let's just do this. It's nothing too special on this one. Hold on, let me turn off the light. Okay, let's do this. All right, so we need C rows, count rows. Now just call it rows. Oh yeah, we just need the rows, right? Just ones row. Okay. No, not okay. So before that, we need to grid down length. Is it good? Yeah, at least one. That's fine. M is grid 0 dot length. Okay. New int m. That's the number of count. We're gonna say count of ones for each row. You spelled it wrong. And we do the same. We say ones column is new int n, which is a count of ones for each column. And then we just say for int I, 0i smaller than m, I plus plus. For j equal to 0, j smaller than n, j plus plus. And then we say ones row plus ones row I, that's the ith row, plus equal to grid ij, and ones column j plus equal to grid I. That's actually exactly the same as yesterday, right? And then we're done. Now we're gonna create int got diff equal to new int m n. Okay. Then we'll go again for int I, 0i m, I plus plus. For int j, 0j smaller than n, j plus plus. Right? And then we all say diff ij equal to basically ones row I plus ones column j minus The 0 on this row is n minus 1's row I, right? This is the number of zeros on this row. And minus m minus 1's column j. All right, blah, blah, blah. Then we return diff. Let's see. Let's see, is this correctamundo? Yep. Oh, I've done this before. It's not the fastest that I had expected. Oh, this must be a contest, I think. Yeah, this feels like a contest to me. Some contest I've done in the past. Find the count of ones for each row and a column, then compute diff directly. The count of zeros can be computed as m minus count column or n minus count row. Okay, go here. It's T 2023. This is 14. Oopsie doozy. Okay. What was my solution here? I don't remember. Oh yeah, the same idea. Okay, so we're done with this. All right, we're back to this. So save. All right, so the idea, right? We go back to the idea of monotonic. So yeah, we need to do monotonic on this one. So here's why. So basically, right? So we have some values, doesn't matter. It's just, and then we have a new value, okay? And if we do monotonic increasing, there's only, at most, there'll be 3 values, right? It'll be 3 values because you have one more, then that more, the difference will be more than, like the difference will be 1, and then this difference will be 1. This is the maximum we can do. But there could be, you know, many repeats, but it's fine. What we want, these are the last occurring, okay? These are the last occurring value. So if the v, our current value comes in, if v is within the range, right? So we have, this is the smallest, this is the largest. So we know what's what, right? So if the v comes in, it's within the range, then we will do whatever monotonic array will do. Okay, we incorporate it in, and it will pop. And then this is actually, the value is going to be some a, and then its index. You know, it's going to be ai, a0, and then a1, i1, a2, i2. We'll put the index as well. So the v comes in, we might pop some stuff, right? But it doesn't matter. So we get its index as well. So if v is larger than this, I mean, it depends, right? So it's outside, right? It's outside. So it's outside then if v is larger than this, okay? If v is larger than this. So if v, because this is the last one, right? No matter what, this is going to be the last one. We either pop something or just put it. This is the last one. So v, if v is 2 times bigger than this, that's it. V is we're gonna start fresh from here. Everything there we just compute whatever it is because it cannot extend here, so we have to start fresh. So that's so if v is 1 bigger, if v is equal to this, right, then we just incorporate. If v is 1 bigger than this, right, v is 1 bigger than this, then if we only have, if v is 1 bigger than this, but now we know it's not gonna work, right? Which means v must be, and if v it's not gonna work, and it's not too bigger than this, right? Then it it depends, right? It depends. So if v is bigger than this, but it doesn't work, so that must mean, and then v is not too bigger than this, that must mean v is too bigger than the start, right? Than the current smallest value. So it must be more than 2 bigger than this, which means in this case we need to pop this. Okay, and not really pop this because we know v cannot be incorporated into this range, right? So since v cannot be incorporated, we need to remove this one, right? We need to remove this one. And what we do know is because this is monotonic increasing, so every value in between these two is larger than this, because we also pop the same, right? So we know everything in between these two is larger than this. So anything between these two can fit this v, right? Can fit this v. So basically we go from front to the v. So like this is a bad. It's actually no. We go from here, right? We go this is good. Like if this is bad, then this. If this is good, we check this. If this is good, we check this, and this is bad, right? Then we know this is good, so we need to record a low, which is the start. So from low to this, everything we can count. And then we set a new low shall be this index plus 1 will be the new low. Then we keep going, right? So that's when v is too big. Now there's also another situation where v is too small. So we also need a monotonic decreasing array. The same thing, right? So v is small. If v is not working and v is smaller than the last one, then v.
Instruction you said to fill measuring cup with water?
Yeah, a third cup of water.
We don't have another measuring cup, right?
No, we do. You had one, I remember. Well, in Boynton. I don't know if you brought it.
In Boynton?
Yeah, remember we have 2. You have a glass one. Really?
I was in the studio.
Maybe you're right. No, I think that's the only measuring cup we have. Unfortunately. I'll wash dishes, by the way. Alright, where was I? Yeah, so if it doesn't work and it's actually smaller, right? If it's smaller, then we do the same thing. So it's the current value is too small. So again, we do this. Is this good? Is this good? And then if this is something is not good, then these need to be popped. Okay, these need to be popped. And I am still debating what type of popping we're gonna do. Right? What type of popping we're gonna do? Do we just use a deck so we can just pop? Or we simply, because the length is only 3, so maybe we can just recreate.
Yeah,
We need a bathing suit?
Well, if you want to go to the beach or...
Good call. I did not bring it. Got it. Oh, come on, fit. Let's fit. Oh. 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 Hmm?
You can't fit anymore?
Well, after the graduation, I can fit a lot more because I have my laptop to return, and I have I'll say wedding gown.
Oh. You're gonna mail it back over there?
Yeah, I'm not bringing it back.
You're bringing a box?
Yeah, I'm bringing the box. That's what it takes a lot of space. All right, let's go back. So yeah, if it's too small, again, so we'll do this. So I think I'm not gonna even use, there's only 3, so a deck is not necessary. I just recreate the stack, and then you put it in. And it's actually smaller, so it's actually just appended after. Right, and you go, yeah, I think it does sound like a good strategy, which we will not actually use any of those. We don't even need to use, so what we're gonna do is all the way to 17, right? We just delete everything and we start fresh, okay? We start fresh. So we're gonna have a stack, let's call it increasing stack and decreasing, so it's inc stack, okay? And we have deck stack, right? So I have 2 stacks, and we're gonna go one by one, and for each one we first check, we can put the first value in it, right? We can put the first value in it because it's okay. It's gonna be num 0, right? We do num 0 in it, and there will always be something in the stack, okay? So for I in range 1 to line nums, okay? So now we're gonna go through each one by one, right? And then for each one, we're gonna check, right? We're gonna check if it works, if it doesn't work. Oh, hold a second, that is not right. What we need is a index. We need the index as well. We need this. That's not right. I have no idea what I'm trying to do. There we go. What? Oh, I have to do 2 times. Okay, that's okay. All right, so for here, from 1 to the end, so each one come out, we need to first check. So if ABS So monotonic increasing and then decreasing, they all have the values, right? No matter what, they all contain the max and they contain the min. It shall be the same. The ones in between might not be the same. So see, that's the thing. I'm not sure. Do we really need two? The increasing array. Oh yeah, we do need two. Right? We do need two. Oh, but what is going to be like if you're increasing array and now you have the smallest, you have a very small comes in and then you just pop everybody, then what is the large value? You don't even have the large value. How are you going to resolve that? Well, if you have a small comment, or maybe it doesn't matter, right? What really matters is if you are too big, right? Let me think again. The monotonic increasing, right? And then you have a small value comes in, which is within range. So you will pop, right? Pop. So that's like the most recent one is the smallest. Now you have something too big comes in. Yeah, I think it might work. I think it works. So I don't even think we need to do this. Right? All we do is for the stack, we check if the current one is the difference between the current one, right? If it's too bigger or too smaller than the end, right? If it's within the range, then we just, put it in, right? We just put it in. And for the increasing array, we will always append something bigger. If the decreasing array, we'll always input something smaller, right? Yeah, if it's within the end, then we will do whatever we need to do to update. If it's not within, right? If it's not within, then we will, it depends, right? If it's too big, right? If it's too big, then we go whichever is fails, right? If it's too small, let me think, if it's too small, then I'm saying you have to go monotonic decreasing array, right? If it's too small. So you go, but why would you go monotonic decreasing array if it's too small? Well, if it's too small, the thing is it's right, it doesn't really matter, right? If it's too big, too small, you always just go back, right? We can just do the increasing, right? If it's too small, then if it's one bigger, right? No, if it's one smaller is fine. If it's really small, then yeah, it cannot do, right? I'm confused by myself. Yeah, so if it's just a little bit small, okay, a little bit small, and then you just go. It doesn't matter. Oh, it does matter. It does matter if it's, yeah. So imagine your monotonic increasing array, and then you have a small value. So it pop everybody out. So now on the stack, you have only one value, and now you have a new value comes in, which is one smaller than that. Right? In that case, you have to use, yeah, you have to. I mean, there's no other way, right? There's no other way. So yep. So it depends, right? So it depends on whether it's too big or too small, right? Whether it's too big or too small. So the value, if the value, we can just say if nums I, right, is larger than increasing stack minus 1, 0, right? If it's larger than that, then we need to walk back on the increasing stack to find which one is bad, right? So we just say for, okay, j in range, len increasing stack minus 1, minus 1, minus 1, right? So we say if if increasing stack j 0, okay, actually it's not gonna be, it's gonna be nums, right? If nums I minus increasing stack is larger than 2, right? If we find something that's larger than 2, this is when we have to, handle this situation. How do we handle? Well, we know increasing stack j at this position, this is the bad one, right? So this has to be cut out, okay? So res shall plus equal to, right? So from low all the way to increasing stack j, actually 1 to that index. Everything in this, right? Everything in this is all good. Everybody inside this is all good. So that is going to, we're gonna say count, right? The number count shall equal to increase stack j 1, right? That minus low plus 1. This is the total count. So what we're gonna do is count plus 1 times count divided by 2. That's the total amount that we can do. And after we do that, we need to reinstate, right? So the increasing stack shall equal to increasing stack from j plus 1 to the end, right? Because this one is gone. But before we do it, low need to be reinstated as increase stack j 1 plus 1, right? That's the next low. And then we redo increasing stack, and then we'll break it. Done, right? And if we go through the whole the stack and none of them is bigger than 2, and that's good, right? We don't have to do anything. So that's that. We just go through them and we say elif nums I is smaller than decreasing stack minus 1, 0. So this is too small. So again, we use the almost same logic. So we will just copy. Let's just copy this, right? Let's copy this and make some changes. For instance, all the increasing stack shall be decreasing stack. Okay, I should do this. It should be decreasing, right? So the next one we should update. Okay. So we have decreasing stack, and then this is, because it's a decreasing, so everybody is bigger, so I need to make changes. So this need to go basically minus nums I, right? So we say decreasing stack is 0, j0 minus this if it's larger than 2. Count is going to be oh, aren't we supposed to have 2 of them? That is interesting. The low. The low. What are we gonna do with the low? Is it the same low or we need 2 lows? That's a good question. So if we have something big, right? It's bigger than, you know, like basically the current max. Then on the other side, it should immediately, the first one, right? The first one shall be bad, right? The first one shall be bad. But, yeah, hold on. So if I'm larger than the increasing, right? If I'm larger than the increase, now I'd definitely be larger than the decreasing. And then I only handle the increasing, so I, you know, update the low or whatnot. Then on the decreasing side, ooh, what are we gonna do on the decreasing side? See, that's why I have 1 is just really not the most convenient. I know. But we have to, because if the current one is smaller, there really is no way for us to know. But how do we handle the low? It shouldn't matter, right? The low should be the same low. It doesn't matter if you are in the increasing or in the decreasing. It doesn't really matter. So if we do this, right? And then on the decreasing side, I will pop something and then we will stop. That's not true. That's not true, because on the increasing side, if I have something big, right? And on the decreasing side, it will pop everybody, so we only have this. And then we have something even bigger comes in, and then it would just pop this one, right? It would just pop this one. Because that's something bigger, right? Something bigger than the... Yeah, so the increasing and decreasing will look very similar. The last value is always the same. So if it's bigger, then on the other side, it will just pop it, right? It will just... And we will handle it. If it's too small, then we'll also pop, right? It's smaller than, yeah. If it's too small, it's smaller than the smallest. So for the increasing, it will pop everybody else. I think it's fine, right? I think it's fine. I think it's fine. And yeah, I think it should be fine. And of course, if it's too small, the first one gets popped, and then the count is decreasing is minus low plus 1. Rest for this. Lower you go to decreasing stack plus 1. Decreasing stack will be this. So basically we do these two, and after that we'll update, right? We say update the stacks. So while increasing stack and increasing stack minus 1, 0. This is increasing, so if this is larger or equal to num's I, right? If it's larger or equal to num's I, so num's I is small, right? Num's I is small, then this dot pop. And then we try it again until num's I is bigger, right? And then once it's done, I say this dot append num's I and I. Okay, so again, while dec and decreasing stack minus 1, 0 is smaller or equal to num size. So something is really small here, right? Something is, no, this num size is big, then we will dot pop. And at the end, this will dot append num's I. So we'll go through every single one. At the end, we'll return res. All right, this is a challenge. Let's see. So first is 5, 4, 2, 4, and this one we shall return 8. Second one is 1, 2, 3. This one we shall return 6. Now we have nums, right? This is continuous subarray, and then this is nums. Is that right? Oh my goodness, it was terrible. That was terrible. All right, let's figure out. Let's just maybe we try the second one. I don't know why the second one is not right. Oh, because I didn't do it after we go through everybody. Ah, that's right. Once we get out, right? Once we get out. And I think we only need to do, it's just low and the last one, right? So at the end, we shall say count again shall equal to nums minus 1 minus low plus 1, right? Minus low, that's the last one. And then we can say return res plus, count plus 1 times count divided by 2. Is this right? Now this is correct. Now the first one's still not correct, so we're gonna have to figure it out. Result is 7. I'm missing something. Okay, I'm missing something. Did I miss the first one by itself? I do not think so, because in this case 5, 4, right? 5, 4. So yeah, let's write it again. So in my idea, 5 is a start. So we have the increasing and then we have the decreasing. Okay, they all start with 5. And then 4. 4 is smaller. So increasing, 4 is smaller. So I don't do this. I do this. 4 is smaller. We check this is not, right? So nothing happens. So the decreasing array, actually we need to remove this. Right, decreasing array now becomes this. And increasing array becomes 4. Okay, the next 2 2 comes in. 2 is smaller, so we don't do this, we do this. Smaller 2 is, so this is good, but this is bad. Okay, this is bad. So what I do is I say this 5 is bad, and 5 is at the 0 position. So I'll take the count is 1. So 1 times 2 divided by 2 is 1, right? So now we have 1, which is 5 by itself. But I'm missing 5, 4. You're missing it. That's right, you're missing. So it has to be this entire thing, man. It has to be the entire thing. It has to be the entire thing. Oh, but it cannot be the entire thing. So hold on. So we have ba 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 ba. This one is bad. This is the bad one. And then we have ba ba ba. So that's the current, right? And then we have the value comes in. So this is the bad one. So what we need to do is everybody start from here. This, like this all the way. This is all the way, and this is all the way. And then we move the low to here. So this is not right, okay? This is not. So what we need to do is to find from low to this, to n minus 1, right? Low to n minus 1, and then to I minus 1. So this one will be the total count, like 1, 2, 3, 4, 5, 6, 7. It'll be 7, right? It will be 7. So low to this, because we're going to do this. So it'll be this plus, so basically we have count, right? Count is I minus 1 minus low plus 1. That's the count. And what we need to do is count plus count minus 1 plus plus this thing. And this thing is what? It's index, right? It's index. I know it's index. And we just need to know this, the count. So count front and then count end. Count. Yeah, okay, so I think I know what went wrong. So basically here, right? So if I have something that's too bigger, we need to do, hold on, that's not right. Count left, right, shall equal to, it's I minus 1, or it is I minus 1. That's the most recent one, right? That's the most recent one. So it should be I minus 1 minus low plus 1. So I minus low, that's the count left. And count right shall equal to I minus 1 minus int stack j 1, right? And then plus 1, which we're gonna remove this. So that's the count right. And what we do is, this is not right, okay? So we count left plus all the way to count right. So we should say count right plus count left, right? Count left. And then how many are there? Well, will be because count left is bigger, so it should be count left minus count right, right? So 4, 3, 2. So 4 minus 2 plus 1. And then divided by, can we do like say CL? Let's do CL, okay. Let's do CL. This is CR. Okay, CL and a CR. This should be CR, right? This should be CL, and this is CL. This is CR. So that's the result. Okay, and after that we reset load to this. We update it into scat. Okay, that's good. And here we'll basically do the same thing. And I do think it is the same. So we'll yank all this. Then we'll paste all this and delete this. Right, so CL again is I minus low. CR is, this is not increasing, this is decreasing stack. And after that, the rest is equal to this, low equal to this. So if we do that, then we pass. Let's check one more time. Okay. I think we're ready to see I mean, we can throw in some right? I don't know, just whatever value you can think of, just put it inside. All right, see. How about everybody's the same? Okay, I think I have one more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. How about this one? All right, give this a shot. All right, it is correct. It is correct. So now that we know it's correct, maybe we can make it look a little bit nicer. I mean, I don't know. Making it look nicer. How are you gonna make it look nicer? I don't know. It looks pretty nice to me already. Okay, so let's just document what we did, and no, that's not what we want. We want to go 32K. Okay, so we're gonna do this and this, and go up. We say, the essence of the problem, right, is that given an array, given nums, I to j, right? Given nums I to j that are continuous, right? Continuous, and with any pairs not differ by more than 2. Now we have the next value, nums j plus 1, right? If it also falls in line we simply extend the array. However, if nums j plus 1 is too big or too small, we need to find the rightmost value in nums I to j that differ from nums j plus 1 by more than 2. And the next continuous subarray will start from the right neighbor of this value. So how can we find this value without going back one by one? I use monotonic stack. Okay, but 2 stacks to be exact, one increasing and the other decreasing. Since the diff within a good continuous stack is only 2, is no more than 2, the size of the stack will not be more than 3. And if nums j plus 1 is too big, we go through the monotonic increasing stack and increase stack from right to left to identify the rightmost value that cannot fit nums j plus 1, right? Since we record its index and also the index of the start of the current subarray, we can easily compute the total number of subarrays in that range. Then we reset the stack by removing all the elements to the left of the miss. I need to give a name. V. Okay, let's call it V. And also the index of the start of the easily compute the total number of arrays in the range. And then we reset by removing all the matter to the left of V, including V, right? And push the current value into the stack. If nums j plus 1 is too small, we use the monotonic decreasing stack the same way as described above. Salud! So the total runtime will be ON for this. That's why it's not too bad. Yeah, tough question. I do think it's a tough question. If I had encountered this one in the interview today, I might not be able to solve this, honestly. Because this one took me like 2 nights, right? 2 nights. But luckily the interview today was not that bad. Deck. I use a deck. Okay, so it's a sliding window with a deck. Oh, now that I'm thinking about sliding window, I think I know what it's talking about. But how do you keep track of the max and min? So like you just keep extending to the right, and then the first one you find that's not good, so you're shrinking on the left until you go past. Yes, that's ON. That's a sliding window. But how do you know something is bad? You know something is bad, so you keep track of min and max, right? You keep track of min and max. Oh, you don't? No, you still, right? You still do. It's a good question. How do you keep track? Well, and I don't see a min. There is a min and max. There is a min and max. We have a min, we have a max. So we keep track of the min and max that we are allowed. Min and max is allowed in this range. And if the new one comes in, which is outside this range, then we move from left to right. If does not belong to range, try to remove from I minus 1. See, that is the problem. You try to move from I minus 1. Now this, we can go all the way down. That's not a sliding window. Huh. Because the current one is outside the range. Okay? Current one is outside the range. And we say we have a new range given the current one. And then every one, while nums j is larger or equal to this, and nums j is smaller, so it's within the range of the new one. Okay, update j minus minus. Huh. If I remove from this, I'm thinking of going left to right, but this is actually going right to left, which does make sense, right? Which does make sense. Go right to left, and then we find the first one that doesn't work. And this just keep going forward, and then we find the first one that doesn't work, which is fine. find the first one that does not work. And then we keep moving forward. Hey, how is this not O square, right? Thanks. Didn't hear you. Because if you go all the way to the left, alright? If you go all the way to the left, you have a new low and high, right? You have a new low and a high. And you keep going. Then if it's too big or too small, the next round you won't go as much. I mean, that doesn't make sense. Yeah, there'll definitely be someone in the current range which is bad, right? Which is bad. So the worst case will be the bad ones at the front. So at this case, you will walk all the way to the front. But it's fine, right? It's fine. And now you have the new range, and the next one comes in, and then we'll keep going. If the next one is bad as well, right? If the next one is bad as well, then you don't have to walk all the way back, because it won't happen. Yeah, you can imagine if we have a small value at the front and everyone else is larger than 2 and the new one's like larger again, then you have to walk all the way back, right? But then because these two are so similar, so the next one is different, then you will walk very early to reach. Yeah, still, I don't feel it's a good proof. I don't feel it's a good proof. But I get the general idea, which is very similar to how I was trying to solve it before. Monotonic makes me feel more comfortable, but this is correct. I do agree. This is correct. Yeah, let's write this tomorrow. Let's write this tomorrow. I mean, I should think about sliding window, right? Yeah, I should think about sliding window. Oh, this says to use a set-on map to keep track of the max and the min subarrays. We don't need to do that. I like the other method, right? So every time, you keep the range. You have the min and max. You have the range, and each time a new value, a value that's outside range comes in, and the outside range value will definitely determine one of the min or the max. So you go from there and you go left, right? And then that's how you find the first one that doesn't fit, right? You find the first one that doesn't fit. And when you do that, then everybody else, you know what they are, and you compute, right? You compute their value, all good. And you move forward. I think I'll still use my idea to do the computation, but in this answer, they add right away. You see that? They add it right away. J is the front, right? Yeah, J is the front. So every time we add a new value, you add I minus I agree, right? Every time you add a new one, you add this. That's good. And when you do this, that's true. That is true. You can think of this is the total number of subarrays ending, not starting, ending at nums I, right? Ending at nums I. So every time we add it, we compute. And we add it, we have to compute. It's a good one. It's a good one. Okay. Yeah, I want to do it tomorrow again. All right, that'll be it. I will see you guys tomorrow. Adios.